Okay, so yesterday we were talking about SD-WAN technology.
Okay.
Okay, so this technology, as I mentioned, this technology is new tech. I mean, uh, changing the behavior or pattern for the WAN connection. Okay, so it's serving different way for the WAN connection. Using SD-WAN, what you can do, you can use the dedicated circuit. Dedicated circuit means if you have MPLS or any other circuit, broadband circuit, you can use that, okay, with security, okay, because this the technology works on two terms. One is overlay network and other is a underlay network. Underlay network is providing the connectivity and overlay network is used for the communication. Okay, so when you have a connectivity, post having the connectivity, it creates a tunnel for secure connection and it sends the data over the tunnel instead of sending the data using instead of sending the data directly. Okay, it would be using use tunnel network to send the data. So yesterday we talked about that if you have if you have to distinguish between overlay and underlay network, so you can see this diagram. So you can see here underlay network, which is your physical infrastructure that is defined in the second picture. Okay, here it is showing that how your network is connected, but to send data, all the devices would be using a tunnel mechanism and it would be using the SD-WAN cloud to share the data. Okay, so once you have a underlay network, after underlay network, it is creating the tunnel to the, and this is known as a virtual infrastructure, which is known as a overlay network. So these are the edge router. They are creating a tunnel through SD-WAN controller, and then SD-WAN controller is creating a tunnel to another edge router, and the traffic is going via this controller, via this tunnel. Okay, moving to next. In Cisco world, we have Viptela. Okay, so Viptela is a SD-WAN solution. It is from Cisco. So there are so many companies which is having the SD-WAN product. Cisco also introduced its SD-WAN product, and that product is called Viptela. Okay. Apart from Cisco, there are other company, for example, Meraki also providing the SD-WAN capability. Okay, and there is a Silver Peak. There is another company which is providing, SD-WAN capability. So because we are learning Cisco, so we will talk about this Viptela solution. In Cisco Viptela, we have 4 plane. One is the data plane, other is a control plane, the next is management plane, and final is orchestration plane. Okay, so we will talk about them one by one. What is the use of these plane? So if you talk about data plane, what data plane is basically doing? What data plane basically doing? Okay, let me just discuss about that.
Okay.
So data plane is basically used to exchange the data over the SD-WAN network. So let's say you have SD-WAN network like this. You have branch office. This is branch 1, branch 2, branch 3. So these are communicating how? These are communicating via, I mean, whenever the data is transferred between these branches, it is transferring through data plane, right? That's the use of data plane. Okay. So we would have a edge router over here. That is SD-WAN edge router. Later you would understand what are the edge router. available for the Cisco SD-WAN. Okay, so these are the edge router, and you can see this is a SD-WAN network, which is connecting to these. All edge router is connected via this way, and if the communication is happening, so it is happening through SD-WAN network. I mean, there would be virtual tunnel is going to be created between the branch, and the communication would be happening through this virtual tunnel. So data plane is working over here, where data is transferring from one branch to another branch. So here data plane is working. Next we have control plane. So control plane, if you just want to push a particular policy over here, okay, so you are pushing the policy through the control plane. So you are controlling, instead of in control plane, we can say that protocol which is used for exchange all these data, that works on the control plane. So you might have a OSPF, IPsec, all these protocol is working where on this control plane. And then you have a management plane. Okay, so what is the management plane? Basically, if you just want to manage your SD-WAN network, that means if you just want to access this router so that you can push the policy, so for that you can use the management plane. Okay, so management plane to manage SD-WAN network. And yet you can do the orchestration as well. If you just want to include any API kind of stuff, okay, any kind of orchestration, automation, so you can do via this orchestration plane. Okay, and to support all these, we have a different component in our Viptela. So let's talk about that.
Amar, this control plane and management plane is a bit confusing.
Yeah, so control plane is your basically your protocol which is working over the overlay or underlay for the connectivity. So that is working as a control plane. And management plane, if you just want to manage entire SD-WAN network, so you could be managing through management plane.
Like example, you gave control plane OSPF IPsec to control the
Communication.
data traffic. And what can we give the example for the management plane?
Yeah, management plane to access the device. For example, if you want to configure the device, okay, you just want to access this device, which is as a router. So how you would be accessing through the management plane?
Okay.
Okay, so for communication, you would have a different interface. Okay, which is for OSPF connectivity, the neighborship established would by different interface. Okay, but for management connectivity, you would be using a management interface. So that comes under the management plane.
And what was orchestration plane?
Sorry, orchestration plane. It's basically any kind of provisioning you want. So you can do this via orchestration plane. So provisioning means if you just want to, do any kind of API stuff. For example, let's say you just want to do the monitoring, like how much utilization of the bandwidth and what is the utilization of the bandwidth in different branch. So for that, what you can do, you can use this orchestration plane to automate the task. So any kind of automation, if you want to do, you can do via this orchestration plane.
This is used for automation thing.
Yeah, it's the automation or API kind of stuff can we use here on the orchestration plane.
API, what API?
That's a application programming interface. That's a full form of API. So basically what is happening, API, you can say this is a device. Okay, this is a device, and this is what this is let's say API. So let's say here are the user. This is a user. If user want to interact with this device, basically your user in the sense your, let's say Python script something. Okay, so if it want to interact with device, so this script language is understood by this API, and then API would be interacting with the device.
Translator.
Okay, so it is working as a yes, it is working as a translator over here, which is uh, you know uh, understanding the language of any kind of programming language, and it is converting to the desired input for the device, input or output.
And
So
API is
I
used
can
Cisco
say
term.
no, it's not Cisco terms. It's normal in the programming, basically programming and automation. You would be learning this API.
This doesn't belong to Cisco API.
This doesn't belongs to Cisco. This is simple programming and automation terms. So it would be supported by all kind of device, even your Palo Alto
Mhm.
or SD-WAN or some kind
FortiGate.
of FortiGate, yeah, or any device. Nowadays they are supporting API. So what happened? Basically, the device manufacturer, for example, Cisco in the case, they would create one API, and that API can be used for uh, can be used for the automation task. So for example, let's say this is Cisco device. Okay, this is Cisco device. So what Cisco would do, maybe router, it is Cisco router. So for Cisco router, they would develop one API, and in that API, it would be the code would be written that how that, I mean, if someone want to access, interface information, whether interface of or not. Okay. So let's say someone run the programming code, and using that programming code, it want to know that whether interface is up or not. So instead of running command, okay, instead of direct, you can get the interface status by the command as well. So instead of running command, okay, they would define that on API what code they need to call. Okay, and basically there is one API which is very famous, REST API. This REST API is very famous. So any company is developing their API in a REST format. We will talk about this during our automation part, but they are interacting, I mean orchestration plane, this is used for automation, and how your automation script interacting with the device, it is interacting with API. Okay, so suppose I written some automation script. So I would be using some language, for example, I would be using Python, or I would be using let's say JSON. I would be using JSON. I would be using. These are the automation script I can use. But what code I need to call so that this device can give the information and or execute my command? That code I would get from the API. So each company has their API, and this is the public. I mean, this is not a private. You can search over the internet and you would be able to get the API for managing Cisco device or managing, Viptela. So you would get that API. In that API, it would be written that if you want to know the interface information, so you have to inbuild XYZ code in your programming. So what this Python script would do, Python script is going to execute that code. And based on that code, this device is going to give the information back to the Python. So on the Python console itself, you would be able to know the information. Okay, so API is nothing but this is a small program which used to interact with the device in a programming format, not in the human format. You would be using programming script, and you would be putting the API code so that this programming script can interact with the device. So we used to do the provisioning. Provisioning means, let's say, what I just want to do that if someone is raising a ticket to access XYZ website via Cisco router or via API. So what it does, it user fulfill the form, and as soon as it click on submit, automatic my device is going to validate whether that website is legitimate, and if it looks like legitimate, automatic that rule on the firewall gets open. So that's the benefit of orchestration. So if you want to do any kind of automated provisioning, so you can do via this or orchestration.
Some disturbance are there in the line, Amar.
Is still disturbance? Just give me a minute. Now,
Kind of air sound.
now it's better.
Yeah, now it's clear.
Okay. So that is the use of API. So we have three plane: data plane, control plane, management plane, and orchestration plane. Data plane is purely for the data. And control plane, if you just want to control the communication, okay, either using routing protocol or using the policy, etc. Okay, so you can use this control plane. Okay, any kind of policy enforcement you just want to do, either for your protocol or any kind of communication, so you can use this control plane. And management plane, if you just want to manage SD-WAN devices, so you can use this management plane. And finally, orchestration, this is used for the automation, or you can say this is used for the auto provisioning. Auto provisioning. So that's what Viptela is. Okay, let me just move further. Here you can see this is the SD-WAN implementation. Basically, when you use Cisco Viptela, so Viptela has the four component. Basically, four component is what? One is the vManage. This is the user interface. Basically, this is a management plane. Using this, you can access the device. That's a vManage. This is the user management. You can access the device using orchestration as well. That means using vWAN. So instead of using putting username and password manually, what you can do, you can use any kind of scripting. As I told, Python, any kind of scripting you can use. And in that scripting, you can call Cisco API, this Cisco SD-WAN API. Through SD-WAN API, you can access this management plane, through your SD-WAN. And if you don't want to do any kind of automation, for example, let's say you have a 10, let's say 10 location, and for 10 location, you just want to know the information that what is the use of bandwidth in each location. Okay, so instead of going each location one by one, you can use the automation script, and that automation script you can run with the vWAN. vWAN is used for the orchestration. So using this vWAN, you can run the automation script. Correct. So that's the use of management and orchestration plane. Then we have vSmart. So as I told, this is a brain, or you can do the policy enforcements using this Be smart, and this is basically control plane. And for the communication between SD-WAN to the edge device, what it is using, it is using OMP protocol. Okay, and using the OMP protocol, it is communicating to the edge device. Okay, so basically you would have some centralized portal. Let's say this is a centralized portal, and through this centralized portal you can create the policy, you can push the policy to end device, which is edge device. This is Cisco edge device. Let's say someone is saying that on this edge device you need to enable firewall or IPS or URL filtering. How you can do that? You can use the portal, log in to the portal using the user interface using vmanage, and once you log in, there would be the connectivity in between. Okay, between portal and this edge device. When you push the policy for enabling the firewall, IPS, URL filtering, etc. Okay, or you just want to do any kind of routing, etc. Okay, so for that, what you can do, you can access this control plane, which is your vSmart, and using vSmart, you can directly communicate to this edge router, and whatever feature you just want to enable on this edge router, you can do that. Okay, so whenever any user which is behind this trying to access internet or something, okay, so basically this as per pushed policy, this device is going to act. Okay, got my point. And finally, this is edge device, which is Cisco edge. This is nothing but these are the router. So far you have learned either it may be physical device or it would be virtual, or it may be a cloud-based portal. This is the physical device. Okay, the Cisco edge router is physical device, and this is used in the data plane. So actually these devices are transferring the data from branch office to the headquarters, or whatever the network is behind this router, that this router is basically transferring the data, and that's why it is known as a data plane.
This is the edge router which you was talking before, right? On SD-WAN, we
Right,
will have the
right.
edge device. So that's the edge
Correct.
router. In that edge
That's
router,
a edge router.
we will have one internet link as well as one MPLS link
LAN,
or something like that.
whatever. I mean, you have the WAN connectivity and broadband link. Both it would be.
Yeah.
If you
So
see
you was
this second
hmm,
one, this one. So if you see this, what is happening here in this? You have V1, you have vmanage, and you have a um, sorry, you have V1, you have a vmanage, and you have the orchestration, right? So all these things you have. And using this, you can see this is over the cloud. That means it is somewhere on the portal. Okay, like previously I talked over here. So we have vmanage, we have vbond, we have vsmart. This is where this is over the portal. Okay, and how it is connecting? It is connecting using secure networking. So there is kind of OMP protocol, which is this one, and this would be using a secure connection between your edge router. These edge router is where? These edge router is on each offices. Okay, so these are the each offices on this edge router on each offices, and basically how it is connected. It may be connected through LTE, it may be connected to MPLS, it may be connected, all these branches may be connected using satellite network. But basically, the communication which would happen between these branches, the communication would not happen directly. It would happen through SD-WAN, and you can see the communication is happening how over here via edge router. One edge router is communicating to another edge router, another edge router is communicating to another edge router, and this is how the communication is happening. And if we want to control the policy, we just want to do the orchestration. Okay, so how we are doing, we are doing from this portal. This is portal. This portal is having all those things. So it has vBond.
It's a management thing, portal.
We manage, yes, this is B manage. We have a vSmart. All those things we have. So basically, if you see this is the management plane. This is orchestration plane. This is a control plane. So we have all these plane, which is available where? It is available somewhere on the portal. Okay. And through this, you can control all your SD-WAN. You can manage all your SD-WAN network. This data plane is dumb device. Okay. It would not work if it do not have a policy. Okay. So policy from where it is getting the policy? It's getting policy from here. From control plane, it would get the policy. How you would access this control plane, etc.? You would be accessing through the management, because user login would happen through management only. Okay, or you can log in. You can, if you don't want to use user login, so basically script, any kind of automation you can use over here. Leave on. Any confusion?
Everything is new, SD-WAN.
That's why.
So, but I remember you said this SD-WAN is very helpful for you personally, because in MPLS, if the link is down, you can't troubleshoot. But in SD-WAN, if the link down, so you have the another internet link connected to that edge device. So I believe it's edge router. You directly connect with that edge device and you can configure it.
Basically, I can let you know that whenever you are going to configure SD-WAN, let's say this is a branch. So this branch is connected to your HQ using two mechanisms. This is HQ. It is using two links to connect to HQ. One is from, let's say, Bharti link. Another it is using, let's say, Tata link. There are two links to connect to this branch. And further it is connected to HQ. Now, if you are just using normal, routing mechanism, so basically at a time, maybe you can utilize both link, or maybe you can't utilize. Okay, maybe you are utilizing equally, or maybe you are not utilizing either one of the link at a time. But when you are using SD-WAN, so basically, because this is underlay network, okay, so using SD-WAN, you can utilize both link. If one of the link get failed, no problem, your traffic would go via another link. And using the SD-WAN, it's very easy to divide the bandwidth in the percentage. For example, I can say that 40% of data would go via Bharti and 60% data would go via Tata. If both link gets failed, sorry, one of the link gets failed, so another link would be start sending the 100% data. So this is really very easy. Okay, and if you have third link as well, that's a MPLS, let's say, sorry, broadband. So if these link goes down, so then your SD-WAN immediately would create the connection via this link. So this is what the benefit you get in the SD-WAN. You can divide your bandwidth. You can do the load balancing of traffic.
But this
And
uh, unequal cost load balancing is the EIGRP term, right? Or the feature that
yes, that's a
SD-WAN is doing over there.
EIGRP feature.
Hmm.
But SD-WAN would be able to do this.
Ah, okay.
Yeah,
The unequal cost load balancing,
yeah, it would be able to
40%.
do that. I
Oh.
mean, here is unequal cost is not applicable in the SD-WAN. It is really depending on your IPsec
Mhm.
tunnel or maybe GRE tunnel. It would be depending on these tunnels.
How we have configured that thing, it depends upon that.
Yes,
Okay.
it's a very rich interface. If I show you, let me see if the rich interface. You can see this is very rich interface. This is silver peak orchestration, and here you can see the interface. These are the device location edge routers, and here it is showing that how it is connected. So each location is connected via 2, 3, 4 virtual link. You can see
It's a virtual link connected. Okay.
this is a virtual link. This is not physical link. Okay,
Okay.
physical connectivity would be 1 or 2, but virtual connectivity would be more
Mm-hmm.
than that. And you can from manage all these through centralized portal. Okay, if I type Cisco Viptela, the portal would looks like this. This is Cisco V manage, and you can see this is the portal.
Mm-hmm.
To the, I mean, first user logging to this one, to the V manage, and through V manage, it can access other component and try to push the policy.
Like V-bond or what was that?
Yes,
V-bond and
we want V smart.
V-smart. From V-manage, we can access that V-bond, V-smart. We
Yes,
can do the policies. Okay.
so
And this
that's what it is.
ASR's 1000 series router, these are the Nexus routers or something else?
These are the ASR 1000 series are the edge router basically.
Hmm.
If uh, if you talk about these routers, so these router is directly connecting to your ISP, okay,
Mhm.
and this is able to handle a lot of BGP routes.
Mhm.
Yeah, so it's a ASR series router, and this would be used as a edge router.
But this is
Edge
Cisco
router
or
means for
the
internet
Nexus?
access. Yes,
Hmm.
sorry, this is
It's a
not
Cisco
Nexus.
or Nexus? Not
This is
Nexus.
Cisco
Okay.
is itself. It is ISR series basically, ISR or ASR series router.
Mhm.
This is different than uh, your normal router, because these router have a high processor and high memory. It would be simply you can run all those Cisco command over here, but hardware of this one is more robust, you can say,
Okay.
than the normal router.
High configuration compared to the legacy
Yeah,
router or the
yes,
old router.
yes, right. I mean, the CPU and memory of these router is really very high, and you can use on the edge network. If you have a data center,
Mm.
so on data center for the for internet connection, you can use ISR or ASR router.
And plus, they're gonna support this fiber optics, 100 GB, 40 GB, that kind of things.
Yes, yes, that it is supporting because you would get SFP on that those router.
Mm.
So using SFP, yes, you can use fiber optical cable.
SFP is the module for the thing, fiber optic.
SFP looks like this. You might have seen that. Instead of fixed port, this is SFP.
Okay,
These are the SFP.
port. Okay,
Yeah. So you can see over here. This is the fixed port. Okay.
okay,
These are
LAN
the
port.
fixed
Okay,
port, LAN port,
Ethernet port. Sorry. Okay.
Ethernet port. So let's say
Okay.
this Ethernet port is what? This Ethernet port is supporting 100 Mbps, right?
Yeah, or maybe gig. Okay.
Maybe giga as well.
Yeah,
But if you use a fixed port over here, you would get the fixed things. Okay.
correct.
For example, on this Ethernet port, you can't plug fiber optical. But
Correct.
if you have SFP kind of stuff,
Mm-hmm.
so you can use the fiber optical SFP,
Mm-hmm.
and whenever you require, you can use the fiber optical SFP,
Mm-hmm.
and whenever you require LAN based, I mean UTP1, so you can use UTP1 SFP. That's what it is. This is so this is not fixed. You can remove it from the router or from the device. That's what the SFP.
It's a module. Like we can
This is the module,
remove.
right?
We can,
This is the module.
but once you remove, I don't think so. We can put what is it? Line. Okay, we have fine. We have another this thing. SFP VoIP E converter something is there where
Yes,
we can
right.
put
We
line.
have different type of SFP.
Okay,
SFP
okay,
you would get for the LAN side, I mean for Ethernet port, and SFP
okay.
you would get for the
Fiber
optical
opticals.
port.
Okay,
Okay. So yes, we have different type of SFP. This is the fiber optic LC port you can see here.
uh,
This is the fiber optic SFP.
correct.
This one as well. This is the line one.
Line one.
So that's the SFP. Yeah. So we have different series of router. Okay.
Okay.
And yes, that can be used as a edge router. So if you are selecting edge router for Cisco Viptela, so recommendation is go with the ISR or ASR or 4000 series of router.
Okay.
Yeah. So that's what SD-WAN. Okay. It's a
And
very good thing, SD-WAN, I would say, because the connectivity, legacy connectivity is really very slow. Okay.
correct.
And really very hard to manage. But what if you get single ported to manage all your network? It would be really easy, right? Instead of
Correct.
going on each router one by one. So if you get the single ported, this is really very helpful. Yeah. Any other question?
This ISR and ASR, when we can think what device or what is the difference between this thing, like
I
if
mean,
it comes under interview.
you can refer to data sheet. So basically, each router would have a data sheet. So if you go to ASR 1000, let's say, so you just go with the ASR 1000 data sheet, and you can check here the ASR 1000 data sheet. So you would be able to know that what all the things it is providing. So you can see this is the data sheet of your
Okay.
ASR router. So you can refer the data sheet and you can check that whether this is fit for your requirement or not. So You can open two data sheet, one for ASR and one for ISR, and you would be able to know that
Okay.
whether this is fulfilling your requirement or not.
Okay.
Yeah. So data sheet is really important. That's what we used to do basically. Whenever we required, I mean, when we just want to suggest to the customer that which router is good for him. So first we get the, requirement from the customer. They give the requirement that their users in the data center around, let's say they would be saying that the traffic from the data center would go for the 10,000 user or 5,000 user. Okay, and they would say that in a 1 day, or sorry, the data traffic maximum for 1 day is around, let's say they are saying 1 Gbps or 2 Gbps. So according to that, you can calculate that which router would be good for them.
Amar,
So
you
this
are
data
audible,
sheet. Mhm.
but there are so many disturbance in the line, or I don't know
No,
what's happening. Are you able to hear the same thing which I'm hearing? No.
for me it's okay. I can voice very well. For me it's okay. I can hear your voice very well.
But some like something is smashing over there, or some air sound is coming in between.
Just give me a minute. Now,
Now it's okay, but after it starts.
okay. Whenever it start, you can just.
Sure, sure.
Okay, so this is really helpful. This data sheet is really helpful for you to understand the difference between with different router, and you can compare with that. I would say go and read the data sheet for different
It
routers
shows the
or
configuration
switches.
of the device, how much
Yeah.
capable of this. Okay.
Yes. Okay. Now I'm going to next slide. This is slide number 2, and now I would go to slide number 3. So I would talk about switching mechanism over here. So we have different type of switching mechanism. One switching mechanism is process switching. What is this process switching? Let's try to understand that what this process switching does basically. In process switching, processor would be directly involved with each packet, each and every packet. Okay. So I would say like
Still,
this.
sound is coming from the background.
Why this is